A shortened coffee break. Those of you who were once in college, remember you had 10 minutes to get from one lecture to the next? I'm pleased to welcome our final plenary speaker of the afternoon, Dr. Jill Barron, an ecosystem ecologist at the U.S. Geological Survey and a senior research ecologist at Colorado State University, previously a research scientist with the National Park Service. For many years, Jill has conducted long-term monitoring and research on air pollution impacts in national parks, especially in montane ecosystems, grappling with the science and policy challenges of environmental threats that traverse freely across park boundaries. She was lead author on the report on climate change adaptation options for national parks, released in 2012, and is also the current past president of the Ecological Society of America. And for those of you who've been keeping track, we've had 3 ESA presidents on the stage today. Jane Lubchenco was also president in the 90s, and Jill and Monica Turner. Jill's talk today is titled Protecting National Parks from Air Pollution Effects, Making Sausage from Science and Policy.
So David, you had asked Monica Turner about links between the Ecological Society and National Park Service, and I've noticed another one this afternoon, which is the disproportionate number of papers published about national parks in Ecological Society of America journals. So there's a strong linkage here. And I think it's no surprise that pollution talks go last. Pollution is always such a downer. And so here I am, I'm going to be talking. This is the topic I was given to talk to you today, this afternoon. And actually, I am going to talk about it, and it's a tremendous success story instead of being a downer. So first, before I start, I want to introduce my co-authors. Ruth Alexander and Mark Fiji are environmental historians, and we have been studying together for the past year on the premise that a knowledge of history as well as ecology can better inform resource stewardship. And I think that it's bearing some fruit. Tamara Blett is a long-term National Park Service Air Resources Division employee. You'll meet her a little bit later. And Bill Maughan, well, I have to talk about Bill first of all by talking about myself. I was recently introduced at a meeting as being the grandmother of Colorado research on nitrogen deposition and policy. Now, I was surprised. But if I'm the grandmother, then Bill Maughan is absolutely the grandfather, if not the founding father, of visibility research and a whole lot of good that has come from it with the National Park Service. So here is actually going to be my punchline, my solution slide, and if you want, you can check out for the rest of the talk. But it all begins with the science, of course. Without the scientific foundation for making management decisions, national parks, as you've heard over and over again, are flying by the seat of their pants. So the science is foundational, but the science is insufficient for protecting landscapes that look like that. For that, you actually need a group of policy analysts and people who can take the science and put it to use and make recommendations. And here I'm going to give a lot of credit to the Air Resources Division of the National Park Service. In the middle, you see Tamara Blett. She is what we call a boundary spanner. She's trained as a scientist, but she is a consummate communicator, and she takes the science that we give to her, and she puts it to use addressing the kinds of good that it can be put to use. Now, I have to mention also that the Air Resources Division is full of lawyers in the National Park Service, and they are legal lions. And here's Chris Shaver, and Chris Shaver's sitting right here in the audience, as an example of how this type of air pollution information has been put to such good use. So the idea is that they take the science that we produce, and they put it through this alphabet soup of stuff, where they figure out which parts of science can be used, for example, to address air quality-related values, or perhaps whether there would be possibilities of transportation of pollutants from different power plants that would cause prevention of significant deterioration. And this is actually where the sausage actually happens, because I have no idea how this works, but it does, because they take our science and they translate it into something useful that can be put to use. And just as an example, there are more than 100 power plants in this country that were never built because of the kind of science, air pollution science, that was provided in order to put the Park Service to use. Now, ideally, because Park Service is not a regulatory agency, they take that information and they give it to those groups that are, the states and the Environmental Protection Agency. But because, and I think Dan Simberloff mentioned this earlier, federal agencies are very risk averse. They have a tremendous reluctance to act. And the status quo is just fine, thank you very much. So sometimes this works, and it works well when it does, but in many cases they need a little nudge. And this is our essential fourth partner in almost all of the science that gets done. And you've heard this again several times throughout the day, that we need our nonprofit, our non-governmental organizations, our citizens and stakeholder groups who care about conservation, who care about protection. And they have been absolutely essential to giving little nudges to regulatory agencies in order to make this whole circle, starting with the science, to actually work. So here's the outline of what I want to do. Remember, I've been working with historians for the past year, so I want to take us back in time, and I want to talk about internal management and external threats back in the day before there was actually an air resources division. I'm going to do this with a couple of examples. I'm going to talk about visibility, and I'm going to talk about atmospheric deposition. And through that, I'm going to talk about how the science gets put into practice, and I'll end with some of the challenges ahead. So let's get started. Most resource management takes place, and when people think of it, this is what they think about. Most people in the country who visit national parks, as we've heard already, they come to see the wild furry animals. They like to see that. And this was endorsed all the way through as long as there had been resource managers, first by the Leopold Report, we've heard that mentioned several times today, and then by Mission 66. What did they hire when they were told to hire scientists? They hired wildlife biologists. The idea for management in national parks for many years was that you could manage the resources by looking within park boundaries, and you did not have to worry about external threats from outside. Now, external threats had been mentioned in a couple of documents as early as 1980, and they called out specifically air and water pollution, but really there was nothing much done about it until there were a couple of very important congressional acts. So at the end of the 1970s, we were riding high on the environmental movement. There was a Congress that was moved to act in order to protect air quality. So the Clean Air Act of 1977 had a bunch of words in it, including to preserve, protect, and enhance the air quality in national parks. This was huge. This was the very first time that the Park Service had ever been told, you have to care about this particular type of resource. And all of a sudden, it gave the Park Service a new mission that they had to address. And they did, and I'll talk about that when I talk about visibility. A few years later was another very important congressional act. So the first one gave a legal responsibility, an affirmative responsibility to the Park Service to protect its air. The second one didn't do that. It said you have to do research. And this wasn't directed only at the National Park Service, but the National Acid Precipitation Assessment Program was a sweeping 10-year research program authorized by Congress to find out what was going on with acid rain. Remember, in the early 70s, Gene Likens published a report from Hubbard Brook that showed that acid rain was this serious problem that was acidifying lakes in the Adirondacks and killing fish. Well, almost every member of Congress, probably to this day, is a fly fisherman. And this made a big difference. But we knew very little back then about what was going on with acid rain. Where was it? How extensive was it? If it was falling, what kinds of effects was it happening? And to the great credit of the National Park Service, they scarfed up some of the research money and they put it to good use. Now, I want to go back here to this research because this is the way resource management was back in the 1980s and going into the 1990s. It was focused on wildlife and maybe forest management and a little bit of fire. And here we come doing air quality research, and it was full of these ugly spaghetti diagrams. It was complex, it was not intuitive, it was chemical reactions affecting multiple receptors, and it had to do with source receptor and complex chemical transformations. It goes without saying that we were not extremely welcome within the National Park Service. And I say we because at this time, the newly formed Air and Water Resources Division, one division, was formed, and I was hired into it. So there were 4 of us in this entire division. There were 2 water experts, and there was the division chief, whose name was Ray Herman. I'll come back to Ray, and myself, and he hired me to work on acid rain. Today, just as a note, there are almost 100 water resources experts and air resources experts in the National Park Service today. So we started a movement back then. Let me talk to you about visibility. So here's our visibility example here. This is what millions of people come every year to see. This is what they get. or this is what they got, I should say, because this came to the concern of one, Bill Maughan. Bill's down there by a trailer on the bottom of the picture. And in 1977, he was working for some think tank out of California, and he managed to publish a paper called The Excellent but Deteriorating Air Quality in the Lake Powell Region. Now, he knows that because he practically invented the science of how you measure the backscatter of haze, particles in the atmosphere, and what that does to view sheds over time. Not only did he and his colleagues invent the science to measure this, he also, they had to invent the models that then tracked it back over time to its sources, and that is the beginning of this success story. So he published this foundational paper. Then we started to get legal reviews because remember, the Park Service is required to keep the air clean in national parks. We also got media releases, lots of publicity about this kind of things. There was a National Research Council review of air quality, and the citizens groups all got involved too. So there was this huge public outcry about visibility, and not only within Grand Canyon National Parks, although that was where the very first lawsuits and actual battles about air quality came about. And I have to say that those battles were won, by and large, by the National Park Service because of the foundation of data that actually happened. But visibility wasn't a problem only in Grand Canyon. You can see there are parks here all over the country. All of them had bad days, and they were due to haze. They were due to air pollution-caused haze. So over time, the kinds of data that were produced, again, not the things that people think of if they're thinking about necessarily wildlife management, but there were lots of chemistry and lots of visibility and lots of pictures back and forth, and they led to the models that led to the policy analysis. And of course there were lawsuits. The power plants pushed back because a lot of these analyses pointed to specific sources of air pollution. They said, you have got to clean up. And so they sued, and there were lawsuits, and over time, though, the Park Service ended up winning. And it was a remarkable story because out of that came a cleanup. There was again, founded on the science, many hundreds of visibility-related articles in the open literature. So without that foundation, it wouldn't have been easy to win these lawsuits. I'm sure it wasn't easy anyway. But it provided the basis for saying, yes, we know what we're talking about, and this is credible, and you are causing this cause of these types of problems. So over time, we have cleaned up a great many national parks. There are now 157 visibility monitoring sites in the nation. All of them either show significant improvement or no decline in air quality over time. But that's not all. If you look at what has happened, certainly parks were not the only ones addressing haze and air pollution efforts over the country, but it was a significant part in actually cleaning up air quality for the entire United States. So here's a graph on the bottom. It goes from 1980 up to 2013. And over that time period, between 30 and 55% of the emissions have declined from nasty characters in the air: nitrogen oxides, volatile organic carbon, carbon monoxide, sulfur dioxide. And this has occurred at the same time as GDP, vehicle miles, population, and energy consumption have all increased. So you can thank the Park Service for having cleaner air nationally. I'm going to move to my second example and start talking about atmospheric deposition. So this is a picture of Ray Herman. He was the division chief of our little 4-person division, and he got some of the air pollution, the National Acid Precipitation Assessment money, and he put it to work. And remember, our charge was to find out where in the National Park Service, National Park System, were there, first of all, were there sensitive ecosystems? Where were they? How much acid rain was falling? And if so, what was happening there? So in his vision, he actually took this money and used it as startup to set up 4 long-term watersheds. Those are the little red dots you see there. And all the other words that you can't see are other eventual watershed sites that he established. And I have to say this was true genius at this time because he didn't only think that we would be measuring acid rain forever. What he was doing was establishing long-term instrumented watersheds with the idea that we would keep them going and monitor both the range of natural variability in inputs and outputs and ecological responses within, as well as the changes that would come from atmospheric deposition or whatever kinds of disturbance that would be happening over time. So this is almost true genius because he had this long-term vision that parks needed research and they needed to have these long-term records, and he set this up in 1980. Well, I used this as my get-out-of-jail-free card, and I actually took it to take over the Rocky Mountain National Park research site And I established a long-term research site there called Lockvale Watershed. We just celebrated our 32nd anniversary, and again, we measure and quantify the inputs and outputs of chemicals. Now we interact it with climate change, and we are fortunate to be able to have long-term records of what's going on in alpine and subalpine lakes, forests, as well as alpine tundra. But first, and I have to say, our equipment is very sturdy. It's Park Service brown. I'm eternally grateful to Rocky Mountain National Park for letting us keep it there, even though this is now designated wilderness. We're grandfathered in because the park recognizes the value of science in partnering with them to put it to use. The very first thing that we did is we went back in time. We took our notice of looking for acid rain seriously, and we asked the question, has there been a history of acid rain in this park, and if so, for how long? So we took lake sediment cores from 4 lakes, we went back, we dated them, we used proxies in order to find out whether there was acid rain falling in. You can see the pH trace there going back deeper into the core, older and older, and the answer is no. We really didn't find much acid rain. We did, however, find in subsequent research that starting about 1950, there had been a profound change in the algal assemblages of these alpine lakes. And if you remember this morning, Dr. Wilson talked about algae as being the foundation of primary productivity on this planet. Well, this was something going on in national parks. We dated it to 1950. This is the period of time post-World War II when the state of Colorado rapidly increased, exponentially increased, its human population, its livestock, its industrial feedlot operations, as well as all the energy and transportation that accompany those kinds of things. So we found no evidence of acidification, but instead we found this dramatic shift in algal assemblages that was coincident with nitrogen emissions. So this started us on a 25-year study of the ecological effects of these kinds of air pollutants coming out of the sky, although we called them change over time. And you can see here a diagram that was put together by the Air Resources Division, but it actually exemplifies very well what we looked at. We looked at soil and water chemistry and algae and nitrogen in the waters. We looked at foliar chemistry and alpine communities. That's where we've stopped, because what we found is that we were at the beginning, now we're midway through, a trajectory of change, and our great colleagues who do study acid rain in the eastern United States could tell us what happens next, which is episodic and chronic acidification. So we were not at that stage there, but we knew that we were headed there if nitrogen deposition continued to increase. So with a little nudge, and we published this, and although we didn't rank a National Research Council review, we did have an independent review of all these many papers published about Lockvale and nitrogen, and they said, yes, these data are sound and valid, and National Park Service, you really ought to do something about this. So what they did about this is nothing less than remarkable. This isn't yet a success story because it's still unfolding as we go, but the Park Service got together with EPA and with the state of Colorado, with a little nudge, I have to say, from Environmental Defense and Trout Unlimited, and they developed this remarkable memorandum of understanding that said, not only is this change happening from nitrogen deposition, it's damage, and we want to take it back to a level where Rocky Mountain National Park is not damaged by nitrogen air pollution. So there's a path that's going on. It's a 25-year glide path to take us to half of the nitrogen deposition we receive today. We're working on it. We're monitoring every year in order to see whether we're making any progress. The answer is no, but it's not getting any worse yet so far. And the other remarkable thing is that we've managed to bring in a huge number of local stakeholders. And several people today have talked about the importance of this. It's absolutely critical. And I want you to take a look at who some of these stakeholders are. We got the Colorado dairy farmers. We got the livestock producers. We've got the corn and wheat associations. I mean, these are people who live in Colorado, who love Rocky Mountain National Park, who know they are a major source of pollution to this park, and they don't like that. They would like to be part of the solution. So we meet with them quarterly. We talk about actions that they can take. There are some that are beginning, and it's really a remarkable collaboration that we hope will end in success. And I have to say that if these voluntary measures don't work, there are stricter measures, more stringent measures that could be put in place. So stay tuned to see what happens here, but this may be the path forward for dealing with air pollution that comes, in this case, from agriculture. So I want to talk real briefly about the challenges that lie ahead. Several people have alluded to this already. Climate change is going to interact with all of the air pollution gains that we've already had. And unfortunately, a warmer temperature makes everything worse. We'll see more ozone. We're likely to see more nitrogen oxide emissions. We're likely to see more ecological effects. So the science behind this is unknown, and that's our big challenge as scientists, is to figure out these interactions and then figure out possible solutions that could be given to public land managers in order to take better activity around them. The other is, I think it's very important that the Park Service continue to fight insularity. Now, what I mean by that, and the Park Service has made great gains by working with outside scientists and embracing them and welcoming them in. But there is a recent report, in fact, it's the Colwell report, Leopold Revisited, that calls for greatly beefing up the scientific staff of the National Park Service. I agree with that wholeheartedly, but I want to caution not to become insular in the management, the application of the science, the conduct of the science, because there's such great value to be had by working, yes, with other agencies, I'm not trying to be self-serving, but also with the great universities that have been such a foundation for the National Park Service over time. And then the third thing I want to mention is that I think that it's very important to keep this monitoring going. And yes, it's not just mindless monitoring, but the value of these data only increase with time. So keeping them going, but also evaluating what they mean is absolutely essential to our ability to understand these parks and to manage them into the future. Thank you very much. I'm going to end with this one document, this picture, because I think it takes all of us in order to make this happen. But the science, it starts with the science. Thanks.
So the slide's gone, but you used the sausage metaphor, and we all know that to mean that you really shouldn't look inside. But what you showed wasn't so messy. It was a little black magic, like lawyers take the data and something happens. But is it, something happens. But my question for this would be, as scientists, especially a younger generation of scientists, how much should we actually be educated about what happens, or is it enough to deliver the science in a clear way to people and their job is to sort of make that translation?
So what you've just described is what a colleague of mine calls the loading dock hypothesis. We do a whole bunch of great work, and then we go, here you go. I don't think that works very well unless you have extremely capable and knowledgeable people on the receptive edge. So I think not only is it important to understand the language of these other groups, in our case policymakers, but also it educates us on the kinds of science that they need so that we are better prepared to be able to, yes, do the kinds of hypothesis testing and curiosity-driven science that makes us all very happy, but we can also tailor it to their specific needs. So I think the more communication we have of each other's languages, that's come up earlier already today, I think the better off we all are.
And in this case, you described a very specific policy directive when you can talk about nitrogen loads. And I think a lot of us, on the one hand, would love it if there was just a clear threshold. But as scientists, often we see just this continuum of sort of more is worse or more is better or something. So what is that process of translating the continuous outcome, what we might get from a lot of research, to that sort of policy discrete barrier kind of idea?
You've actually raised a topic that we talk about a lot, because the policy people would say, I need a number, I need that critical load. And we'd be saying, we can't give you a critical load, it depends. And in many cases, it's site-specific, it's ecosystem-specific, and it's going to change. So even in Rocky Mountain National Park, critical loads have been stated and published, going from 1.5 kilograms per hectare per year of nitrogen deposition all the way up to 10 kilograms of nitrogen per hectare per year. One has to do with alpine lake chemistry, the other has to do with alpine tundra. Which do you choose? That becomes a policy decision, and it's, the best science we can give them still isn't going to help them make that decision.
Yeah. So in the face of, especially in the face of climate change, wilderness areas may be, all areas may be threatened. Can we afford to not install new research in wilderness areas? And I'm paraphrasing someone in the audience who asked this question. So you were grandfathered in, but my question is, can we continue to say, but no new projects? We can't, the science is no new projects of your kind of sort of hardware installation, that
So-
the wilderness areas need to be protected from that kind of intervention.
I'm not a manager, so I don't want to presume to say what they would, but if it was up to me, I would allow the research. But I know that they have to make that trade-off every time. Is the knowledge gained more important than the protection of the wilderness? And wilderness is this funny concept. Remember, I've been studying with historians for the past year, and it's a totally human construct, made up by Euro-Americans of their mythic perception of what the wilderness of the United States looked like, when in fact it might have been very different. But it's sort of our vision of paradise over time. But yet they grandfather in all kinds of things. I know that in the Wind River wilderness area that's managed by the Forest Service, there are cattle allowed each year. Is that wilderness? I wouldn't think so. So research, is that wilderness? Yes.
So recently the Supreme Court ruled that CO2 is a pollutant and can be regulated under the Clean Air Act. So is this a lever for the National Park Service to take the tack that you took with air pollution, and is there a wedge there to tackle climate change through that ruling and the kind of legal framework that was used with air pollution?
There might be. There's actually some very exciting things that are going on. If you regulate carbon dioxide, you actually get a lot of co-benefits. One of the co-benefits is you get, as you reduce CO2 emissions from power plants, you tremendously reduce nitrogen oxide from power plants, nitrogen being the source of the air pollution. And of course, if you go to wind and solar, you don't get any nitrogen oxide at all. So you get human health benefits, you get ecological benefits. So the co-benefits of regulating carbon dioxide in the atmosphere for air pollution in many, many ways, mercury, sulfur dioxide, nitrogen, are huge. So it'd be to our benefit. But how that gets addressed by the Park Service policy managers, that's up to them.
Yeah. Okay, well, thank you very much. We move on. Thank you. We are going to set up the stage for our strategic conversation following on these issues. And while they do that, let me fill you in on the rest of today and tomorrow morning, because I know you'll be ready to move on to our next event when we wrap up here. So we are running a little late, but not too bad. And thank you for staying with us and enjoying what's been really a quite informative and exciting day, although sometimes scientists get excited about their results when, of course, the actual results are kind of depressing in some of these studies. We will, when we wrap up this discussion, there's a poster session, and we invite you all to attend. There's also some liquid refreshments accompanying the posters, but of course we know the posters are what will draw you. That is in the Valley Life Sciences building, VLSB. For those of you who don't know Berkeley, there's a lot of people here who do, so follow the crowd. It's out the front door and to the right and down the hill. That will run until 6 o'clock. At 7, there's an event that most of you have probably heard about. It's not formally on our program. The Albright Lecture will be held on this stage, a conversation between Secretary of Interior Sally Jewell and the UC President Janet Napolitano. That is a first come, first serve and free event, which we fully expect to fill this auditorium. As you leave at 4 o'clock, if you do not have a ticket, you can get one now, and that will probably put you well ahead of a line that might form at 5 or 5:30 or 6, we don't know. So if you're interested in attending the lecture, we do recommend that you make sure you have a ticket now. Tomorrow morning, we go into a parallel sessions, talks and posters from students, postdocs, Park Service, lots of people who've brought their recent research. And that often is, of course, the most exciting part of a meeting, to see what's new. And that will be spread between this building, Wheeler, and VLSB, again, starts at 8:30. If you are talking tomorrow morning, and if you have not yet done so, you should either submit your talks to the speaker prep room, which is right outside here to my right. And if that's not possible, please be at your session half an hour before it starts. Okay, we are setting up. I have a couple panelists. Come on up, because you need to get mic'd before we're ready to go. Yeah, we invite you back at 8:30 tomorrow for those sessions, and then we will come back here in the afternoon for a final plenary session and closing closing talks. So our final, our second strategic conversation of the day addresses this theme of stewardship in a changing world, in a changing environment. And in a moment, I'll let our guests and speakers introduce themselves. As we did this morning, you'll notice that we did not do the traditional model of having the speakers come up and be the panel. One, it was an opportunity to have more voices and hear from more people and more perspectives. But we've certainly invited the panelists here, if they wish to pick up on themes that we've heard in the talks this afternoon. And really to take this opportunity to weave together the themes we've heard, to add in their own perspectives. And I have certainly invited them to feel free to cut me off and have a conversation with each other, and not as well as an opportunity to have it be a conversation shared with you. So are we close? Great. I can't go that way. One of the things that's really struck me today is that I don't think it's an accident that so many speakers spoke about parks in a landscape context and the way that they are embedded in a larger landscape. And in some ways it goes against what may be a bit of a myth we've created, that the American tradition of the park was to set it aside and put a fence around it, because really none of our parks have really ever operated that way. So I want to start with that theme, and actually, Josh, start with you. And we spoke this morning about what you called a coexistence model and a separation model for parks, and also perspectives from other parts of the world. So maybe not so much about the history, but in terms of where we're headed the next century, where do you see the U.S. parks and the way we view the U.S. parks, and what lessons that may have been learned from the rest of the world in that context?
Sure. So in my experience, my limited experience in the U.S. and more experience internationally, like we heard quite a bit today about let's just take two extremes. One, preservation, separation model between humans and nature, and a coexistence model, or maybe we heard earlier today, a working landscape. In my view, I think that's roughly a false dichotomy, and where the real innovation that potentially can happen is how we can integrate these different flavors and different approaches between coexistence and preservation, because I think there's good evidence that both of those models can work and in the right context deliver biodiversity benefits. And I think there's consensus that both of those models are underperforming in general in terms of biodiversity protection. So I think it's not either or, but where the real innovation is how can we integrate those models, find the right incentives to incentivize those models to maximize biodiversity benefits, and in some cases biodiversity co-benefits.
And now you're probably wondering who these folks are. I was so excited about our first question. So, Josh, would you like to introduce yourself, and we'll go around?
I'm Josh Donlan. I run a small NGO called Advanced Conservation Strategies that currently focuses on environmental program design, human incentives, and mostly outside of protected areas or integrated with protected areas.
I'm Laurel Larson. I'm an assistant professor here in the geography department, and I also hold a faculty position within the U.S.G.S. I'm a hydroecologist.
I'm Stephanie Carlson. I'm a fish ecologist here on campus. I'm an associate professor in the Department of Environmental Science, Policy, and Management.
And I'm Ray Savageau. I've worked for the National Park Service for 25 years. I'm currently the Associate Director for Natural Resource Stewardship and Science based in Washington, D.C.
And if you've looked at your program, you may notice that David Graeber was invited to join us at the last minute. He couldn't be here, he wasn't able to travel, and Ray kindly offered to step in on very short notice. You may have noticed that in general, we have not asked too many current Park Service employees to take the stage and be put on the spot. But Ray, we know, doesn't mind being put on the spot. So,
Yeah.
So now, if you remember where we were, Stephanie. So I want to sort of segue from that general picture, and you've worked a lot with migratory fish. So here's an example of a species that respects no boundaries. Mm-hmm. So where do you see the management challenges and the opportunities for the Park Service when some of those biodiversity resources are on the move all the time?
That's a great question. I mean, I think today we've heard a lot about the fact that parks aren't these isolated entities and that we need to be thinking about this larger landscape that parks are embedded in. And this is really made very clear when thinking about migratory organisms that move across the boundaries of parks. And so I work quite a bit with anadromous fishes that are basically breeding and rearing in parks, particularly point rays in this region, and then migrating to the ocean and then back again to complete their life cycle. And so for these organisms that have migrations that take them out of the park, in fact, for most of their life cycle, I feel like we need to be thinking about these landscapes outside of the park and how activities outside of the park potentially influence their dynamics. And this is obviously the main theme of Ruth DeFree's talk earlier, that we need to be thinking about particularly conservation in private lands and how we can minimize impacts on some of these organisms that are moving beyond park boundaries, which in fact are probably the vast majority of organisms within the park, migratory and not.
So Ray, now I'll put you on the spot. I think it's easy to see these obstacles. The bison story that we heard earlier, they're all obstacles and challenges and problems. Where are the opportunities for the Park Service in seeing the park as embedded in a larger landscape, the opportunities that could really enhance that mission and that vision of the parks?
So I think it's, over the years, there's, of course, this increasing realization that national parks, the mission of the national park system, depends on a perspective of looking at our parks as part of this broader conservation network, that we're embedded in this broader community of effects. And some of those things are threats. We heard about air quality issues, but some of those are the resources themselves. And so the National Park Service has a policy and a legal obligation to protect those resources, those values. And we heard about the Organic Act and keeping resources unimpaired. For us to succeed in that mission, we have to recognize that those values will not persist if we're not thinking at that broader scale. And so that's going to force the National Park Service to look to opportunities to work outside our boundaries, to see that as part of what natural resource conservation, natural resource management is about. It's not just worrying about the issues and the concerns that may be confined within a particular park unit. The values in that park depend on looking beyond and working with partners and developing those relationships to ensure that persistence over time.
So I want to transition a little bit to some of the science. Some science in the parks will be a combination of observation. We're trying, like Joel Berger's talk, trying to understand the causes of change, for example, in the animal populations. In other cases, we might really be wanting to test out whether management interventions will work, whether a restoration project will work. As scientists, what we would like is 3 to 5 replicates of the restored landscape and 3 to 5 replicates that are the control. And that sometimes begins to make people uncomfortable. It's like, but if it's such a good idea, how can you leave those untreated areas? So Laurel, I know this has come up in your work, but how do we balance that what we might really see as the ideal design to test whether these interventions work with the desire to also be restoring and simply managing, for benefit the landscapes?
Yeah, so this type of statistical design that you talk about works well within and is set within the context of an adaptive management framework. In reality, it's difficult to realize because oftentimes experimental manipulations are quite expensive. They affect large areas, and so we're limited by space. But there's a lot that we can learn from these experiments, even if we don't have full replication. Particularly if it informs our knowledge of processes. Experiments that inform our knowledge of processes enable us to construct simulation models that allow us to extrapolate those effects over space and time. And I think even if we don't achieve ideal statistical replication, it's important to do these experiments because they do provide a data point and they enable us to implement policy on a small scale before spending huge amounts of money to implement it on much larger scales.
And I'd just be happy to open up if there's any other thoughts on that, questions around that theme.
I'll chime in. So a lot of the efforts surrounding fish conservation focus on habitat restoration, and there are a lot of opportunities there to really be learning from from many small efforts that are often unreplicated. And I think that there's been many sort of lost opportunities to learn from those studies in a way that could guide future experimental design and future studies. And so I absolutely agree that we should be trying to do this in a way that we can learn something, even if it's just a single data point, but through synthesis of multiple studies, we can begin to accumulate knowledge that can help kind of guide those restoration projects in the future.
Yeah, there are a lot of opportunities to take advantage of natural experiments. For instance, natural disasters that perturb the system. Right now, there's a big effort focused on studying the Wax Lake Delta, which is the only part of the greater Mississippi River Delta complex where we're actually gaining land. And that resulted from a breach of a levee that happened in the 1960s. So it was an engineering accident that has enabled us to really learn a lot about how coastal wetlands grow and build land. So I think there are a lot of these opportunities that are quite effective and efficient to take advantage of.
I'll just add that this is recently becoming a big issue with payment from environmental services programs, where the science hasn't really kept up as well with the programs compared to, say, the social sector, where there have been randomized designs looking at conditional cash transfers, et cetera. So we really have a lot better understanding of the performance of some of these social programs compared to payment for environmental services program, and there's been a call for more rigor with respect to randomized control designs, et cetera, with the large or small programs.
So Ray, have you ever seen an experiment just rejected because the design was just so incompatible with a park's goal?
I think that rarely are they rejected because of statistical design. I think that sometimes, right, exactly, for better or worse. I think that it's one of the things, though, that the National Park Service, I think, has a responsibility to also be doing is when we are doing things on the ground. I mean, there are restoration activities, there's lots of various management actions that are being taken, but to look at those as opportunities to learn and to reach out to universities and other scientists to make sure that when those actions are taken, that the information that's collected from them is done in a way that provides statistically robust information about how we make our decisions and to inform future decisions. Yeah. I would reach out to universities and researchers to help us do that. We need that information.
So one of the experiments that is being done, either intentionally or not, will be species reintroductions, or, as we heard about this afternoon, sometimes it's eradications. But Josh, I wonder if you could start on questions about, and I know many people may know that you've been involved in rewilding dialogues in the past, about what are those criteria of whether something's native? Because some of the things that we're proposing to reintroduce may have been gone from a system for a long time, and yet they're certainly not an alien species in the sense that they were brought from Asia or South Africa. It's a very different kind of situation.
Sure, so my take on that is if you look a little bit back in the history, in the 1980s, Jansen really started to get ecologists, Dan Jansen started getting ecologists think about the history matters. And then over the past 10 years, I think the conservation field has started to talk about and realize that history matters, ecological history, and that perhaps more importantly, from a North America perspective, history doesn't start at 1492 and goes way further back. And I think that there's some great national park examples that provide case studies for that in terms of thought experiments, and if you think about them long enough, make your head hurt. Anacapa Island rats is a great example where the eradication of rats, which I helped participate in, was justified. The biodiversity benefits were huge, and it was a clear invasive species. Other areas aren't so cut and dry. The Bolson tortoise, for example, is a large tortoise that the fossil record shows was all over the Southwest, but was not considered a candidate for reintroduction into Big Bend National Park because it was quote-unquote invasive species. And whether or not it's an invasive species really depends on your view of ecological history. And the California condor, which is probably one of the best examples in the US, huge conservation success story, but much of the evidence suggests that the last time condors were in the Grand Canyon was 13,000 years ago. So is it a native or non-native species really depends on your view of ecological history. And
if we do, to the extent that we can hold on to the idea that we don't want to introduce non-native species into a system. Actually, Stephanie, a question for you. Does it apply as equally to introducing non-native genes? Because certainly in the face of climate change, there's a lot of discussion that a lot of the movement that may occur is not just moving species, but whether it's intentional movement or the natural movement of different genotypes across the landscape.
It's a fascinating question, and I think that people are maybe a little bit more comfortable thinking about moving genes than moving species to places where to places that might become suitable in the future. So you can imagine trying to move a few organisms from a warm adapted place to a more northerly place to try and introduce those genes into that population to make that population more resilient in the future. This hasn't been done widely, but it's certainly something that people are discussing actually pretty actively related to corals in Australia right now. There's quite a bit of research on this possibility. So I do think that this is going to become a larger part of the discussion in the future, whether we should be actively trying to introduce genes into systems that'll make those populations more resilient. Some people are, of course, very uncomfortable with this idea, the idea that we could be playing God in these systems as opposed to just sort of standing back and taking more of a hands-off approach. So there's some societal decisions there to be made as well.
And the National Park Service, as a public agency, is responsive to a lot of those societal perceptions and values. And there are policy issues, and the policies neatly define things like what's an invasive and what's not. But when you superimpose all of those, nice policies on top of dynamic ecosystems, the answers are not always clear-cut. And I think that what we're definitely seeing now during a period of more rapid environmental change occurring, the Park Service is going to have to grapple with these questions, and we're going to have to grapple with them more frequently, and it's going to open up a scientific discourse, but also a policy and a values discourse that will influence those kinds of decisions. And we saw earlier in the earlier presentations this sort of evolution from parks sort of being thought of it as vignettes, and then sort of a recognition that change occurs to this, more dynamic perspective that not only is change occurring, but it's occurring in trajectories that are very difficult to predict. And so that makes this whole question about what is impairment and how does one define that, and how does one intervene in ways to try to manage against things like resource impairment, all that more difficult. Policy components, science information, the interplay between them.
So does I guess my first question is whether the existing legislation that we have covers some of these scenarios, and are these more issues of legislative problems, or are they lack of science, lack of data problems that we just need more science to back it up? Are they within the policy mandate of the Park Service to take these on, and you have everything you need to set out new policies that could tackle some of these issues?
And we've heard a bit several times today about this Revisiting Leopold report, and that one of the essential messages there is that there is a dynamic environment out there within which parks are embedded, and how does the National Park Service grapple with that? Is the policy sufficient? Are the policies sufficient in that kind of new world? And there is a group right now in the National Park Service addressing that very question. Are our policies sufficient for addressing these challenges that we are facing as an agency? And so I think that in some ways sort of the jury is out. I will say, though, that as I mentioned earlier, we know that the threats, the challenges that resources face, and we know that the resources themselves exist in this broader network. And so our mission right now, as it currently is written, says that the National Park Service has an obligation to protect those values. And the only way we can do that is to be thinking in this broader scale. So we know that, and we can do that now. So our mission, in a sense, dictates that. It becomes more of these nuanced questions and these details about, well, what does that mean about control of invasives? What does that mean about intervention and what you can or can't introduce? Those sorts of things are the issues that we need to deal with, and we are beginning to deal with, and that I'm hoping the next couple days are going to provide some really interesting insights for us.
I thought you might say answers, which I think would be ambitious.
Insights.
So there's been a lot of talk about biological values today and about the role of whether it's native and invasive species. And Laurel, as someone who thinks a lot about physical processes, I wonder is there really a parallel perspective about what it means to protect, restore, and the physical processes that are ongoing in these ecosystems in a sense that's a little bit separate from how many species are there or which ones are there or their future?
Yeah, it's a great question. I think one of the big challenges that the Park Service or any environmental resource managers are facing in the present day are trade-offs between preserving landscape function and preserving landscape form. One of the challenges that we meet in the Everglades is the fact that currently the Everglades is quite compartmentalized compared to what it was prior to European colonist intervention in South Florida. There's a big effort right now to restore flow to the Everglades, but if we simply remove all of those barriers to flow and let the system flow freely in an unmanaged sense, it's likely that water levels will be much lower than they were historically, which will likely promote vegetation community shifts and inhibit the preservation of habitat for fish and wildlife that we currently value in that area. So we're looking at the question of whether it's better to have an intensively managed system with pulsed flow releases or to remove these barriers to flow and have a much more unmanaged system, but one that is very different from what it was historically. So I think that tension is representative of similar trade-offs in many of the parks.
And do you find that is there a public appreciation for those physical processes? I mean, certainly a half dome is a physical feature that's greatly appreciated, and a lot of the history of the parks was about protecting physical features. And in many ways, our discussion has become much more biologically focused. Maybe biologists helping to organize this meeting had something to do with that. But do you think that in communicating to the public, is there a set of values around the physical processes that are really parallel to the values around native biodiversity and the ecological components?
Yeah, there is a set of values that the different stakeholder groups have associated with those physical properties. In the Everglades, for instance, one of the worries is that by restoring flow to the system, portions of land that are now used for agriculture by Miccosukee tribes might become flooded. And so they have an interest in ensuring that we understand what the system is going to do when we institute pulse flows and remove some of these barriers to flow. Other stakeholder groups, such as the bass fishermen, value the presence of canals within the landscape. And so there is an appreciation, a diverse appreciation for the various physical features of these landscapes.
And Josh, I know in your work in other parts of the world, one of your foci has been how to incentivize private landowners to engage in actions that also serve conservation. So in those, you talked about payment for ecosystem services, so money is an incentive. But what are the other values that you find really motivate people on their own lands to engage in conservation actions, especially if it's in concert with a nearby park or a part of a broader landscape view?
Right, so what we've generally tried to do is instead of kind of normally coming in with our values, be them maybe biodiversity values, we try to engage the local stakeholders, whether they're small-scale fishermen or ranchers in Tierra del Fuego or small communities living in forests, and actually ask them what their values are. And one consistent thing that often comes out of that process is the actual biodiversity benefits, while they might be important, are not top on their list in terms of volunteering into some type of incentive biodiversity conservation program. Rather, does this program align with the way I view the world and the way I live my life? And so there's a lot of value, at least in my view, thinking about learning and mapping the perceptions and incentives of your target stakeholders so you can design a program that they're actually going to sign up for, as opposed to trying to maximize the biodiversity benefits, but then no one signs up for the program because all these programs are largely voluntary. If no one signs up, you're not going to get the landscape level benefits that you're targeting.
So there are people who there are a lot of voices that might suggest we've had a fairly tame discussion relative to some of the projections of climate change, even within this century, as the impacts projected that beyond a 2-degree threshold. So are we even having the right conversation? Are we in the right ballpark of the kinds of challenges that we really might face within the next 100 years for the parks? And that's a pretty vague question. And we're going to wrap up on that. So I'll let you each take a final thought on that or related issues.
I'll start. So thinking about salmon here, we're basically at the southern end of the range for several of the salmonids, and you asked me earlier about potentially assisted evolution, maybe trying to inject genes into populations to try and make them become more resilient. And I think this is on the minds of people, but I think an even more pressing question is just that we have several species that are really on the brink of extinction. We have coho salmon here in Marin County. They are the southernmost wild coho salmon in the world. This past summer, basically this third year of a multi-year drought and the second driest year in California's recorded history, juvenile coho, a decision was made to remove juvenile coho from one of the streams there and to take these organisms into a hatchery setting because there were concerns about the stream drying up. These are very major decisions. These are decisions that are really made when people believe that the risk of leaving an organism in the wild actually is higher than pulling these organisms out and putting them into an artificial setting. I think we're going to be confronted with these kinds of challenges, and these kinds of challenges are going to take a lot of our time and resources. And I think there are some other exercises we can think about in terms of under what conditions might we want to be introducing genes into different environments, but I think a lot of our time is actually going to be eaten up just through trying to stave off extinction of species, particularly at the southern end of the range or range boundaries.
I was going to say, well, in my view, I think most of the challenges and gains, biodiversity gains, if you look at a global scale, are going to be happening in places outside of parks and are going to be happening in places like India, where we heard today, where there's real opportunity costs in terms of getting biodiversity gains. So I think most of the strategies that we've been focused on for the past 40 years are very focused on incremental innovation and probably won't serve us well with respect to the challenges that we have now, and we need to think more about transformative innovation and bringing more entrepreneurial spirits and approaches into biodiversity conservation.
One of the challenges here is that we're not just dealing with simple latitudinal or altitudinal shifts of species. The connectivity of the landscape is very important as species ranges shift as a result of climate change. A lot of times they'll shift into areas that might be unsuitable habitat for other reasons. For instance, in coastal regions with sea level rise, a lot of marshes won't simply shift to higher elevation because there are hard engineering structures present, there are urban landscapes present. And so I do think we really need a lot of innovation in terms of trying to figure out how to maintain connectivity between ecosystems that we presently value and the surrounding landscape in a way that maximizes the resilience of these systems.
Last word to the Park Service.
Yeah, great, for better or worse. Stepping back a little bit, I think that in the National Park System and the National Park Service, we have two sort of big categories of needs for science. And I think everyone sort of touched on those in different ways. There are the sort of here and now challenges, the things that are eating our lunch each day, the imperiled species and the invasive plants and some of these challenges that affect our ability to manage the resources in the parks right now and that have sort of direct implications for the experiences that visitors have when they come to parks. In addition, and often it's part of a continuum, are these longer-term, broader challenges that have system-wide effects, climate change, and you could sort of scale up invasive species as a broader ecosystem challenge. These things that will position the agency for the future. We need science to help us in both of those categories, and we need to recognize that both of those things are important. I am optimistic that, in part, the conversations that are occurring here, but the conversations that we will continue to have over the next several months and years will provide an opportunity for parks to be places where people can actually learn about some of these challenges, these big picture things, the 2 degrees Celsius increase and stuff like that. You can, as a visitor, come to a park now and see this stuff happening. And why not use that as an opportunity to help raise awareness of science, to help educate people about what science is, and to impress upon them the importance of that information in helping us manage resources that I think one nice thing that the National Park Service does have, frankly, unlike many other federal agencies, is that we provide venues for people who come willingly with interest to experience natural and cultural heritage. It's a window of opportunity to help raise, in a sense, the consciousness of the public about these challenges and to get them involved. And so there's an opportunity there. And even though we may not have touched on some of these big challenges, I think that the parks provide a really important window and stage for addressing them.
Well, thank you all for being here today, and I want to thank everyone who logged in online to watch, and thank you to our panel.